Welcome to the tutorial for the new DPSLab software interface. This tutorial video will give you, the user, a look at how the dual-purpose sensor, or DPS, can be used in a laboratory setting. The DPSLab software interface was created in LabVIEW, but does not in any way require the purchase or use of LabVIEW licensed software. This interface is a LabVIEW runtime engine, programmed by Direct Measurements and provided to the user in an easy-to-install and utilize package for Windows. Prior to starting the program, be sure to plug in the DPS sensor head into one of your computer's USB ports, and be sure that all the necessary drivers are installed on your PC, as the program cannot function without the sensor or its drivers. To start, we can see that the DPSLab software has already been installed on my machine. I simply double-click on the icon on my desktop to launch the program. Initially, you will be prompted to either accept or decline the Direct Measurements End User License Agreement, or EULA. You must accept the terms and conditions of this agreement in order to use DPSLab. Once you have accepted the terms and conditions of the license agreement, the software interface's main menu will load. It will prompt the user to select whether or not they will be making a new data log by clicking Lab, or post-process existing data by clicking Log. To begin, we will select Lab and create some new data. Once the user clicks on Lab, they will be prompted with this baseline module. The baseline module contains several components and pieces of information to better allow the user to align the DPS sensor over the linear gauge. As you can see, we have a live camera feed from the sensor head and some streaming text asking me to align the DPS gauge. In order to align the gauge effectively, we want to be viewing the black and white bars of the gauge as straight as possible. Also, attempt to have the image start and stop on the left and right sides with a black bar. Once you have aligned the sensor properly, DPSLab will inform you that it is ready to create a baseline and begin making measurements. By clicking Create Baseline, a baseline image will be captured, and DPSLab will begin logging average strain and individual element strains automatically. As you can see, this version of DPSLab contains a slightly different layout. This layout is broken into two different regions, the Information and Controls region and the Data Display region. In the Information and Controls region, we can see some basic strain, status, and log file information. The active average strain across the entire gauge is displayed here at the top. Adjacent to that, the user can alter Poisson's ratio based upon the material being measured in order to compensate for transverse effects. The number of nodes identified by the camera in the baseline stage of the gauge can be seen here, and the current number of nodes currently being read is displayed here. The current nodal output is active and may change if one or more nodes is lost during the measurement process. Last zero displays the date and specific time of the most recent zeroing of the strain data. The log file size displays the amount of data collected, and elapsed time indicates how long the current log has been running. Located in the same region are the imager and data log settings. The imager settings can be changed to improve the quality of the image and reduce noise in the strain measurement. However, they are set to default values by DMI and should not be changed. Exposure time is an imager setting which can be altered to affect the black and white contrast of the gauge. Increasing this value will make the image lighter, and the latter will make it darker. Gamma is also contrast related, but it should not be changed. Line location is the value in pixels where the measurements for strain are averaged within the image. This setting is also optimized at its default value, but if you are not reading all 17 bars within the field of view, you may change this value up or down to obtain all 17 bars. Both E-strength and E-width are image analysis parameters and should not be changed. NSBR, or number of seconds between reads, is user-defined. Decreasing this value will increase the number of reads and thus the size of your data log and the amount of data collected. Back in the Information and Controls region, we can see the controls for the data measurement and log. The start and stop controls will start and stop the strain measurement process. Only when the strain measurement is stopped will the user be able to alter the imager settings. The zero strain button will reload the baseline module and allow the user to realign the sensor head or just zero the gauge at its current state. The clear log will delete all the information collected during the current log Be sure to save the log file before clearing it. Also, exiting the lab interface will also prompt that the current log file will be deleted, so be sure to save the log file before attempting to exit the program or returning to the main menu. The data display region contains 3 plots. The largest graph along the bottom is an active plot showing average strain versus time, but it also gives the user the ability to pause the graph and view the entire log or to zoom in on specific sets of data. The controls for this graph and how it can be used to export both graphs and data is covered in the operating manual. The spline fit curve, seen here in the upper right-hand corner of the interface, is an active plot displaying both the nodal coordinates within the gauge and the strain intensity. This plot and the color intensity bar below it show individual element strains and are highly sensitive to anomalies. As you can see, I have spread the notch in which the gauge is bonded on top of, and both the spline curve and the color intensity bar indicate its presence. You can also see the average strain for the entire gauge lift off, which is also a clear indication of an anomaly. The strain level at which the color intensity bar turns red is user definable. It can be changed by clicking on the bar and rotating this dial. I will now remove the applied force on the notch in order to return the gauge to a restful state. As you can see, the DPS sensor is extremely sensitive to cracks, and it is also extremely stable when being cycled. In order to save a data log, simply click on the Save Log File button and choose a location for your zip data folder to be stored. Save data in this version of DPSLab works differently than in previous versions. In order to allow for unlimited testing lengths, the logs themselves have to be split up based on the size of the file. Once a data log file hits 20 megabytes, it splits off and a new log file is created. The log files will have a date and time in the name to associate that log file with the specific day and time for when it was created. 20 megabytes does not seem like much. However, in log data points, this translates to roughly 100,000 log strain points per file. The number of 20 megabyte files capable of being captured is only limited by the host computer's storage drive, and therefore longer tests can be captured and viewed in sections or as a whole. Users can prevent their log files from splitting quite so much by increasing the number of seconds between reads, or NSBR. Therefore, strain data will be logged less frequently, preventing this log file from reaching its limit quite so fast. This feature is added in order to make the data collected from DPSLab more manageable and to keep the interface running smoothly. Finally, by clicking the Home button, DPSLab will return to its main menu, allowing the user to post-process captured strain data. To do this, click on the Log button and select a log file. For this example, I will select the one just recently saved in this video. As you can see, once the data loads, it is displayed in the same manner as it was when it was being streamed actively by Lab. The graphs work in the same manner and have identical functionality. Data points can be selected individually, or the cursor can be used to scan through the data more quickly. Overall, Log is meant to complement Lab and provides a means to look at existing data in exactly the same manner as it was captured. Thank you for watching this tutorial video displaying the functions and capabilities of the new DPSLab software interface. Be sure to check out our other tutorial videos from Direct Measurements at www.directmeasure.com or on our YouTube channel, Direct Measure.